All right, today we're doing complex rational expressions. And once again, all together now, what does rational expression mean? Yay, fractions. Charles, I'm not sure I heard you yell fractions out. Good, better. All right. All right, so a complex fraction is a fraction whose numerator, denominator, or both contain fractions. And so below I gave you some examples. Here we have a fraction over a fraction. Here we have a fraction written as a mixed number over a number, which can be written as a fraction. And I think I showed you this before. This is why we got the division sign, something over something. And it's called complex because there are two or more divisions present. Now, a couple of slides ago, actually not slides ago, lessons ago, I promised I'd show you why, if I can get the right color here, why we flip and multiply when we divide. One of the things we look at here is this is a complex fraction. We have a fraction within a fraction. Now, we could make this into, if we had something like this, so let me just get this filled quickly. If we, come on, did that and just ignored the numerator, this would not be a complex fraction anymore because we only have one division present. So watch and learn why you flip and multiply. I'm going to take this and I'm going to multiply this by 8 over 1. It's reciprocal. And when I do that, voila, I'm left with the magic number 1 on the denominator. What I do to one, I have to do to the other. Hey, that's why we flip and multiply. Get it? 1/3 over 1/8 is really 1/3 divided by 1/8. And do you see how we got rid of the denominator? We flipped and multiplied. So that's why this switches into a 1/3 times 8 over 1, because we flip and multiply. And there's the secret of division. All right, so let's look at our examples for today. If we wanted to rewrite this, we could certainly rewrite this as 2a divided by 4a squared over 3. We know division turns into multiplication. And now I can cross cancel. The 2 over a stays the same. The 3 stays the same, but the 4a squared I'm going to factor into 2 times 2 times a squared. Realize the 2's can cancel out, and my final answer is 3 over 2a cubed. A times a squared is how I'm getting that a cubed. Okay, example 2. As with everything, we've got a bit of a more intense problem going on here. This is the questions I love because I get to test you on a couple of different levels. First level, do you realize you have to add before you can divide? Because these are grouped. So I have to, it's like PEMDAS, please excuse my dear Aunt Sally. You're saying, well, I have to do multiplication and division before I do adding and subtraction. Ah, but these are really being parenthesized. They're being grouping. So I'm going to have to do that first. All right. So b over 10 plus 1/2. I'm going to get a common denominator, which is 10. So that means I'm going to multiply top and bottom by 5. and this turns into b over 10, because there's my common denominator, plus 5. Okay, on the bottom, I have b squared over 25 minus, and I'm going to rewrite 1 as 25 over 25, so I can get to my common denominator very quickly. B squared minus 25 over 25. That's great. I did my adding and subtracting. Now I can finally get to my division. So I have to take the numerator, which is b plus 5 over 10, and divide it by my denominator, which is b squared minus 25 over 25. Now, most of you can kind of skip this step right here, and hopefully you can go right to b plus 5 over 10 times 25 over b squared minus 25. That we won't have to do that intermediate step anymore, because you just know you're going to flip. Okay, moving on. I'm going to factor. B plus 5 does not get factored, but 10 can get factored into 5 and 2, because now we have to apply all our rules for multiplying and dividing fractions, which means we have to factor to cancel. So I'm taking my time here and factoring every numerator and every denominator as much as I can. Now I can do some canceling. This is a binomial. This is a binomial. I've got a monomial of 5 that can cancel with a monomial of 5. And I've got a 5 left on top. And I've got a 2 and a b minus 5 left on the bottom. And that is my final answer. All right, this one's a little more. Again, I have to deal with my numerator first, because it's commanding me to add and subtract all this before I divide it by my little itty bitty fraction down there. So I'm going to rewrite 1 as v squared over v squared. Now you're like, wait a second, why v squared? Well, I realize here that I have to get common denominators, and this is already a v squared. So I might as well just take this and rewrite it as v squared over v squared. 1 over v minus 2 over v squared. All right, so what am I going to have to multiply this by to get a common denominator? I'm going to have to multiply both of them by v. So I just like to rewrite everything so it's nice and pretty. So I've got v squared on the top plus a v plus a 2, and I found out my common denominator for that numerator was v squared. That's lovely, but that's still all over 1v. So now I've got a pretty complex fraction. But I know that this means to divide. So I'm just going to take my top fraction and write it back down here. I understand that I'm dividing. So dividing means to multiply by the reciprocal. So I'll reciprocate the last fraction on the bottom there. And wow, it turns out that I can rewrite this v squared as v times v, and they can cancel out. V squared plus v plus 2 is what I have on the numerator, and on the bottom I'm left with a v. And that's my final answer. Nothing more I can do. I can't cancel because this is a trinomial and this is a monomial. You can't cancel unless they're like. All right, last example. Here's my numerator. It's telling me to subtract. Okay, going back into my head, my subtraction laws tell me I have to find a common denominator. Okay, so that means I have to multiply. If I put that under a 1 under there, I have to multiply top and bottom by x. But just for the first 3x over x minus 9 over x. Okay, I can combine that and get 3x minus 9 over x. Great. Done with the numerator. All right, so let's work on the denominator now. I'm gonna take my little shortcut here. I'm actually gonna do this. I'm gonna look at these as one whole term. So that means I'm gonna multiply everybody. I'm gonna use my little shortcut. I'm gonna multiply this by x. So I get x squared minus 8x. And then I'm going to add 15. Now if you remember, we did that a couple of days ago. Remember the fraction like 2 and 2/3? We say 2 times 3 is 6. And then we add on the numerator and we get 8 over 3. Well, that's exactly what I did right here. I looked at this as one whole number. So I did x times the whole number, getting the x squared minus 8x, and then I add on the numerator. All right, so it's division. So I'm going to take this and write 3x minus 9 over x times, flip this, x over x squared minus 8x plus 15. We're now into a division problem, a multiplication problem, which means we factor. So I'm going to take some time here and I'm going to factor the first numerator. This denominator cannot get factored. This numerator cannot get factored. And now this can get factored to, let's see, x minus 3 and x minus 5. Cancel away. Oh, now my dog's coming running. I'm left with a 3, and on the bottom, I'm left with x minus 5. And that is my final answer. You can probably hear her collar jiggling in the background. Done.